Alright, welcome back. So in the previous page, we have mentioned that we can model this relation as a multi-dimensional indexes, right? And we also introduced the queries we can support, with these multiple relation indexes. And the question next will be, how can we construct an index table which can support these kinds of queries in this multi-dimensional space, which will be the target to be studied in the following pages of the slides. So we will introduce different data structure that we can use to support this multi-dimensional index construction. And the first kind of data structure we will introduce here is called KD tree. And the full name of KD tree is actually K-dimensional search trees. And such tree structure is proposed by John Bentley in 1975. If you remember John Bentley, he is also the author of Programming Pearls. I'm not sure if you remember this book or not. Actually, when I'm studying computer science as well as programming in my undergraduate programs, I have read this book. It also covers many interesting techniques and tricks we can play with programming. And if you are interested in this book, you can also refer to it for more information. And according to John Bentley, he proposed this KD tree is an index as data structure. And then high-level idea of this data structure is to split the point sets in the relation alternatively by different coordinates. Now we can by x coordinate first and then by the y coordinate and further, right? So in this page, we can take this two-dimensional space as an example. In other words, we have x and y coordinates only. If the relation has more than two attributes, then the algorithm will also be very similar. But we have to involve multiple high-level coordinates like z coordinate and even high-dimensional coordinates. Let's assume if we have a relation with two attributes and the data tuples that they are not in a two-dimensional space, then how can we construct a KD tree which can construct an index table to speed up the query process? And the algorithm we have for the KD tree data structure is to split the space into according to the x and y coordinates alternatively. For example, we can split by the x coordinate first. In other words, we split by a vertical line in the space, which is denoting the x coordinates, right? Such that half of the points in the relation will be lying in the left region and half of the points will be lying in the right region. Here we need to be very careful, and the splitting criteria is to ensure half of the points. These points denote the data tuples, right? In other words, we can ensure half of the tuples they are lying in one part and the other half are in the other part. It's not according to the x region values actually, it depends on the density of the points in the region or in the space. And it will be in a similar way. We can split by the y coordinate in a similar way. We can split by a horizontal line such that half of the points can be further split into either the above or the below region instead. So you can see the high-level idea of the KD tree is to split the target space of the relation into a smaller region by joining multiple horizontal and vertical lines. Each line we actually split the region or the points into half and half, right? As we have more and more horizontal and vertical lines, we will be able to, split all the data tuples or the points in the space into a very small region, which can enable us to do the queries in a very fast manner. Okay, this is a high-level idea of the KD tree, and let's show you with the example how to construct a KD tree, which can be used as these index tables. And here let's assume we have a feature space with two dimensions, x and y. And here we can construct a KD tree on the right hand side. This denotes the right hand side. This L denotes a line. This line can be either a horizontal line or can be a vertical line. We can have L1, L2, L3, L4, L5, F6 until L9. And this P denotes the points. It denotes the data points or data tuples in the space. And we're splitting this space into multiple regions with multiple layers. Then we can ensure each region we can have only one single point, right? In other words, according to the tree structure, we will be able to search for or query for the data points by following the branches in the tree. So what does this mean? So here this L1 denoting a vertical line. In other words, we are splitting according to the x-axis or the x coordinates. Here this horizontal denoting the x-axis According to a value in the x-axis, we will be able to draw one vertical line, right, to split the x coordinate into two parts. However, here we split according to the density of points. We can ensure half of the points are in the left side and half are in the right hand side. So this is L1 line we are drawing here. It is a vertical line, and we draw the vertical line according to the x-axis, right? And then we have L2 and L3. They are all the lines drawing according to the y coordinates. So given a y value, right, in the left hand side as well as right hand side, we can further split the left region and the right hand side region into two parts as well. So we have L2 to be this line. According to this line, we can split this region into two parts, where P4, P5 above the L2, as well as P1, P3 below the region, and P2 the line on the line. It will be very similar for L3, this line. According to this line, we can partition the region into two parts, where P9, P10 above the region, and P8, P6 below the region. P7 is lying in this line, right? And so this, L2, L3, they are drawn according to the y coordinates. And then we can further draw some lines according to the x coordinate as well, which are the L4, L5, L6, and L7. They are all the vertical lines, right? We have L4 here. It partitions this region into two parts with P1 left hand side, P3 right hand side. And here we have L5, right? It also partitions this region into two parts. We also have L6 and L7. So here we have some regions which may only have one single point, like for the L4, right? We find the right hand side we only have one single data point, P3. In other words, we don't need to further split anymore, and we can just attach one data point to this L4 is road inside the KT tree. As to the region, we can, on the right hand side, as to the region on the left hand side, we can further draw one line, which is L8, to partition this region into two parts, where P1 and P2 they are in different regions, right? It will be similar for the other points as shown in the tree structure. So you can see inside this KT tree, for all the internal nodes, these round nodes, they denote the lines in the space. As to the square nodes or the different nodes, they denote the concrete data tuples and the records in our database system. So according to the internal nodes, we can split the space into multiple regions. We can ensure each node inside the tree structure will have at the most two children nodes, right? Either the left or the right hand side, right? So this is about KT tree we can construct to do the search in the multi-dimensional space. And it can also serve as the index tables to help us to do the search and speed up the query process at time cost.